Hello, how are you everyone? Okay, today we are moving towards the second lecture of May June 2024. Paper version is 42 and this is the paper for theoretical extended question. Before we start our lecture, I have two requests. I have two requests. First one is, if you have not understand the first lecture of paper 42, and then you have to look on the right corner, then where you will get the I button of first lecture of paper 42, where I have solved almost 3 questions in detail. Okay, and second is request is that you must subscribe this channel as soon as possible. The reason is that after a few months, I will privatize my channel. Then you have to pay me to get free access to all the videos. If you subscribe this channel as soon as possible, then you will get free of course lifetime access to get free lectures. Okay, so subscribe this channel as soon as possible so that you can get benefit for a long time. Okay, so now we are moving towards the question number 4, and that is related to the thermal physics. The question is that state two ways the evaporation differs from the boiling. It means you have to give the two differentiation by which evaporation is different from the boiling. Remember, first thing is that I will write here, evaporation evaporation start at any temperature. Evaporation start at any temperature, and on the other hand, if you look on the boiling, but boiling exists only at specific temperature means when the temperature reaches the boiling point of the material, then material starts to boil. But if the temperature is not reached to the boiling point, then in that case your material will not boil. Okay, but in case of evaporation, the material will start to evaporate below the boiling temperature. So this is the big difference between the evaporation and boiling. Specific temperature. Okay, the first difference is that, and second is evaporation starts from the surface of the material. It means the vapors of the liquid starts to converge into the gaseous state from the surface of the liquid. But in the case of boiling, the material the bubble starts to form from the bottom throughout the liquid. Okay, evaporation starts from the surface of the liquid, but in boiling bubbles form throughout the liquid. Okay, this is the two difference, big difference between boiling and uh, evaporation. Okay, you will get easily 2 marks by writing two statements here. Second question is that B part, figure 4.1 shows the part of a container used to store a mixture of liquid and a gaseous oxygen. It means this is the container, and the boundary of the container is isolated with the vacuum steel wall of container. This is the pair of steel wall, and you can see this is the space to whom it has given the name vacuum. Vacuum means there is no availability of air particles. Okay, steel, it is made up of metallic board, metallic material. It means metals. Okay, so question is the temperature of the liquid oxygen is minus 160 degrees Celsius. It means in this container they have placed the liquid oxygen. The temperature of that oxygen is minus 160 degrees Celsius. So question is determine the temperature of a liquid oxygen in Kelvin. It means you have to convert the degrees Celsius into the Kelvin. So to reduce the time of the lecture, I have already solved it. You have to remember this formula. When you have to convert the degree Celsius temperature into this Kelvin, then you have to add only 273. So temperature in Kelvin is equal to 273 plus temperature in degree Celsius. So you have to add, uh, put the value of degree Celsius is minus 160, then you will get here 113 Kelvin. It means the temperature of the uh, gaseous liquid oxygen is 113. So you must write here 113 Kelvin. Is it clear? Second question, the container is made up of steel and there is a vacuum between the inner and the outer wall. The outer wall of the container is at room temperature. State two methods of thermal energy transfer that a vacuum prevents. It means look at the diagram. It has mentioned that there is a vacuum between the two layers of steel walls container. Okay, first layer is this one and our outer layer is this one. In both layers there is vacuum. So we have three mode of transfer method to transfer heat energy. First one is conduction, second one is convection, third one is radiation. So you have the question is that you have to give two method by which energy can not transfer due to the vacuum and the gap between the steel walls. So remember one thing, only radiation can travel through the vacuum. It means the energy that is transferring by the radiation, they can transfer, we cannot stop it. But in other cases convection, for convection, particle of the material moves by itself from hot region to cold region. But here you can look, vacuum is mentioned. It means there is no availability of air particles and there is no availability of liquid particle. That is why convection can by the radiation cannot transfer by the convection. If you look on the conduction method, conduction only happens when things are connect to each other. But in that case, two boundaries are separated by the vacuum. That is why conduction also cannot happen here. So you must write here, heat cannot transfer by the conduction method and by the convection method. No conduction and no convection, only radiation can happen here. Okay, because radiation did not require any material for the transformation of heat energy from hot region to cold region. That's the reason. Next is describe in terms of particles how a gas exert a pressure on the walls of the container. So it is very simple. The gas particles move randomly and collide with each other with the walls of the container. As a result, they exert a pressure on the walls of the container. So I will write, the marks is 3. I will write here 3 points. The gas particle, the gas particles moves randomly, uh, move, right, we have to try to move randomly and collide with each other, also with the walls of container, also with the walls of container. As a result, they exerts a force on the walls of container. So force per unit area is called pressure. So pressure is equal to force per unit area. So that I think it's enough. Now second question number 5. We are moving towards the question number 5. If you have not understand anything, you can ask question in comments, and subscribe this channel and share with your friends to get free access of all the videos. Now question number 5 is figure 5.1 shows a ray of yellow light incident on a glass prism ABC. So this is the yellow light, ABC is the prism, and this light is entering towards the prism without any bending. How is it possible? So we have to look the question. Explain why the ray does not change direction when it enters the prism at face AB. So here is a condition. Remember one thing: when light enters towards the glass or prism uh, perpendicularly with the face look at that here, the light is entering towards the face AB at to, towards the normal. That is why your incident angle will be 0 here, because the angle is parallel to the 90 degree. That is why we say here your incident angle is 0 degrees Celsius. And as I have told you that the light is entering towards the face AB, towards the normal. That is why there will be no reflection here. Look at that, the yellow light is moving towards and entering into the prism without any reflection. Okay, so you have to write at the answer here, the light is entering, the light is entering towards the face AB at the normal. You can also use the word perpendicularly, normal. So incident angle is 0 degree. Okay, so this is your correct answer. Now B part is the critical angle for the glass is 42. Calculate the refractive index of the glass. Show your working. What is critical angle? So when I will upload the lecture of total internal reflection, where I will explain critical angle. Okay, but I will give you little bit information about that. The incident angle at which the refracted rays makes an angle of 90 with the normal, so that incident angle will be called critical angle. So in the question is that you have to uh, find out the refractive index of the glass with the help of critical angle. So look at that, I have solved it on the word file. Refractive index is represented by n is equal to 1 over sine theta. here theta is angle of a critical angle, so you can also use the word c here, okay, instead of this theta. So put the value of theta is 42. Sine 42 is 0.669. Divide this one, you will get 1.5. It means you your light, the speed of light will be decreased by 1.5. Okay, you if you have not don't know the definition of refractive index, then I am giving you the hint. The refractive index gives us the information about the how much speed of light is decreased when it is entering from air to the any medium, just like here glass. You have right here 1.5. Now the second part is on figure 5.1 continues the path of the ray light through the prism and after it leaves the prism. So I will solve it into the uh, whiteboard here. No, we will solve it here. Yes, you have to here you have to draw when light collides with the face AB, then in which direction it will move. Remember here, when light is entering towards the face AB normally, then it will not reflect, and that's why it is moving in straight path. When it hits the BC, it will reflect back here. The reason is that I think the light is entering into this prism with the angle greater than critical angle. That is why uh, to total internal reflection will happen here. Okay, so I will for that purpose, how at which angle it will reflect, you have to draw the normal here. How to draw the normal, I will solve it here. Wait, where is protector? Just where applications, yeah, this is the protector. I will use this protector so you can easily understand how to do that. I will yes, first of all you have to draw a normal. I will point out the location of the normal, mean 90-degree angle. Okay, now I will place here, and I need a scale. Where is scale? Where is, yeah, this one is a scale. Okay, now I will you have to little bit patient because it is very difficult to uh, manage the scale here. So you have to draw a line that is make a normal here with the help of protector. Yes, it is, it's okay. Now you have to draw a normal. Okay, now you have to measure the angle, incident angle. How you will do that? You have to place center at that point and measure this incident angle with the normal of incident rays, so it will be around about equal to the, so if you look at that, it makes angle 60 degrees Celsius. So you must draw a 60-degree angle here. The 60-degree angle is lying here. I will point out in front of you just this one and this one. Now displace it, use the scale, and I will where is, yes, now you have to place it carefully. uh, okay, yes, is it, it is clear now. In this way you have to draw the line here. Okay, no, 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 inside. Okay, it will move towards the reflect towards the phase AC. And one thing more, when it strikes collide with the phase AC, then you have to understand one another scenario. When the light rays are moving from glass to the air, then there will be a refraction phenomena. Refraction means light will bend away from the normal. Okay, so in that case, how you will draw this line, I will give you a little bit hint here. I think there will be it is making a 90-degree with the face AB, so it will move straight here. Yes, it is already making a 90-degree angle again, so it will again move straight here. So I will just like that here. So in this way you have to draw this line, so it is all you will get easily uh, complete marks by doing this. Okay, now move towards the question number C. Internet data can be transferred using infrared wave in the optical fibers. State two advantages of using optical fibers to transmit data. Okay, it is very easy question. The reason is that uh, little loss of data. First advantage is that data is not lost if we send the information with the help of the optical fibers. Second thing, uh, speed speed transmission of data. It means in short and time interval we can send large amount of data. I will write a large amount of data can be sent. Large amount of data is transferred speedily in short time. I will write here in short time. Okay, so I think this is two benefits are enough here. I will add loss of data. Okay, speedy transmission, you can write here speedy transmission also. Now question number 6, that is related to the wave chapter. A sound wave travels through the air. Figure 6.1 shows the pressure time graph for the air at one place. So pressure time graph is shown in sinusoidal pattern, and you have to mention what is this on figure 6.1. Label 1 point S to indicate the compression, label 1 point R to indicate the rarefaction. So remember one thing, the sound is travel in the form of compression and rarefaction. Compression means the region of the uh, sound waves where the particles are very close to each other, and we can say that where the pressure is high, that is called compression. So it means the pressure is high at this position and at this position. So I will write here C. Okay, also here C. These are the compression. But if you look on this one, the region of the sound waves where the particles are far apart to each other, it means particles there is a large distance between the particles, and you can say that there is a less pressure. So less pressure is represented by the trough of the wave. This is the crust. Upper maximum portion of the sinusoidal wave is crust, and bottom portion of this wave is trough. I will write here R. Okay, Okay, this and this one is also R. Okay, now question number 2 is explain why this graph cannot be used to find the wavelength of the sound wave. Yes, exactly. When we talk about the sound wave, we draw a pad of, I will show on the Google, sound waves. You will look, when we talk about the sound waves, we represented the sound waves just like that. Look at that, look at this one. This is the compression and rarefaction. Okay, so we understand it where the particles are closer to each other or far apart to each other. Look at there, this is the compression, this is the rarefaction. So if you look on this one, sinusoidal pattern, we have not correct judgment where the particles will be the uh, in closer path where the particles are far apart. That's why due to the variation in the distance between the particles, we never uh, use the use this pattern to understand the to measure the wavelength. Okay, so due to you have tried here, due to the variation variation among the particles, we, I think it's enough. Due to the variation among the between the particles, you can also add between the particles, we cannot use the sinusoidal pattern. Okay, and we cannot measure the wavelength. We cannot, because we need another pattern, compression and rarefaction pattern proper, that I have shown in the Google. We cannot measure proper wavelength. Now third question is, the sound becomes louder and the lower pitch. State what happens to the amplitude of the wave and frequency of the wave. The loudness of the sound depends upon the amplitude. When amplitude is higher, voice will be louder. I will write here, voice will be louder. When amplitude is high, then voice will be louder. If you talk about the pitch, pitch is related to the frequency. When the pitch of the sound is low, it means frequency is low. Okay, it is very simple. Question number B is, a sound is of frequency 13 kilohertz is transmitted through the water. The speed of the sound is this one. Calculate the wavelength of this sound in the water. So it is very simple question. The frequency is given with 13,000 hertz. The speed of sound in water is 15 meter per second, and you have to measure the wavelength. So in this case, you have to apply the formula V is equal to F lambda, as I have written already, and this is here. V is equal to F lambda. Frequency will be divided on the left side. Put the value of speed is 15,000, frequency is 13,000. You will get here 0.12 meter wavelength. Okay, it is very simple question. I am not going in depth here in that to solve this question. Next is, state the approximately speed of sound in air. It is around about 330 to 350. This is the range of the speed. It depends upon the temperature variations. Okay, so next, last question is, if anybody has not subscribed this channel, so do that, so that you can get free access of all lectures. Okay, Question number 7 is figure 7.1 shows three bars of steel A, B and C. This is these three bars of steel. A student is given the three pieces of steel. Two of the pieces are magnetized and one piece is unmagnetized. Describe and explain how the student determines which piece is unmagnetized using only the three pieces of steel. It means we have three steel bars, and a student is given with the three pieces of steel. Okay, so you have to identify which two pieces are magnetized and which one is unmagnetized. How you can do that? I will write here points, then you can easily understand. Remember, if if you place the piece of steel in front of A, B and C, suppose A, B and C are a nail. I will give you example here. A, B, C are nail, and when you place a piece of steel in front of A, B and C, and if any two of them are attracted with the piece of steel, it means those are unmagnetized. If any one is attracted, it means that will be unmagnetized. If there is a repulsion effect between piece of the steel and bars of steel, it means that are magnetized. Okay, so I will write here uh, what you have to do. You have to place the p piece of steel in in front of steel bar A, B and C respectively. Okay, first point, you have to measure, you have to observe the repulsion and attraction phenomena. Remember, you have to observe if there is repulsion effect, between the end of steel bar and steel pieces, then those those bar will be, or those pieces, uh, and those pieces will be if there is a repulsion, then you have to write here those pieces will be magnetized, magnetic. Okay, magnetic. But if both end of the steel pieces attracts the bar of steel bar, you have tried steel bar, then they will be unmagnetized. Okay, I have give you the hint. if you look the behavior when you place a nail in front of the any in front of magnet, then in that case nail is attracted with the magnet. It means nail is unmagnetized. It is the same scenario that they have asked from you. Okay, so you will get here 4 marks easily. Next is diagram shows a circuit diagram of step down transformer. What is step down transformer? Step down mean where output voltage is less than the input voltage. Okay, so question is the main voltage supplied to the transformer is 240 volt, that is primary voltage. The output power of the transformer is 45 watt. The transformer is 100% efficient. Calculate the input current to the transformer. It is given that the supply input primary supply is 240 volt, the output power is 45 watt. 100% transformer is efficient. It means there is no loss in power. You have to measure the input current. So look at the solution. Input power is equal to output power. The formula of power is product of applied voltage and current. IP is equal to Vp, that is the input power. Output power is secondary current and secondary voltage, but in question it has mentioned the uh, output power directly 45 watt, so I will write here 45 instead of the value of I, S and Vs, secondary current and secondary voltage. We have to put only 45. The Vp primary voltage input voltage is 240. You have to measure the input current IP. 240 will be divided here, you will get 0.19 ampere current, that is the input current. Okay, it is very simple. Next question, draw label diagram of the step down transformer. On the labels state the suitable materials for each of the component. So I have solved it on the, yes, look at the diagram, look at that. I will minimize it. Okay, so I have draw diagram this of step down transformer. How you will find out which one is step down transformer? Remember, this pattern shows that input alternating current AC supply, that is primary voltage. Okay, this is the number of turns, number of loops. You have to measure 1 2 3 4 5 6 7 8. This is the number of turns, that is 8 in the primary coil. But if you look on the secondary coil, 1 2 3 4 5, it means number of turns in secondary coil is less than the number of turns in the primary coil. So this is the diagram of step down transformer. These two parallel lines shows that this is the iron core, this is the secondary turns, this is the secondary voltage that is taken as Vs. Okay, this is the primary turns, and this symbol is the primary voltage Vp. So in this way you have to draw the diagram and label it with arrow signs. As a result you will get easily full marks here. Is it clear? Now I am ending our lectures here. In next video I will solve the remaining, I think 4 questions are remaining. I will solve it in next video. So share this channel with the students, with your friends, and subscribe it to get free access. Goodbye.